All right, so let's go ahead without using any technology. Let's see if we can graph this function. Well, I just wanted to give us a reminder that when we are looking at translations in a function, we can take any function and transform it in this form, where a is the number in front of the function. Remember, the parentheses are going to represent my function. Where a, the number in front, represents stretches or shrinks on my vertical axis. If it's positive, there's no reflection of the function. If it's negative, my function is going to reflect over the x-axis. H is the horizontal movement of my graph, and K is the vertical movement of my graph. So if we try to make this look like this, we can rewrite this graph. Not 1/2. Goodness, this is twice I've made a mistake writing it. The first time I deleted and start over. I'm just going to fix my mistake. There we go. So we've got our function. So the -2 is my a value. Inside the function, there is no h, so there's going to be no horizontal movement of the graph. And on this side, we are not adding or subtracting, so there's no vertical movement. This minus in front, since this is a -2, we are going to reflect over the x-axis. So instead of being this kind of graph, it's going to be this graph. And a is 2, which means we're going to have a vertical stretch of +2. Now, normally, when we are graphing these, you remember we went through those points. But because we're reflecting it over the x-axis, because of the negative, those points for my reciprocal function become important. And because we have a stretch, we're actually going to go up to the 2. Because when x is -1, y is +2. When x is 1, y is -2. And then what's kind of fun too is we can see when I plug in a -2, that's going to give me a 1. Plug in a +2, that's a -2. And so my graph, what I like to do when I'm freehanding my graphs, I know x cannot be 0. X cannot equal 0. That means for us, boom, let me get up. Here, I'm trying to, there we go. That took way too much effort. That means x can never be this value. And because this is a fraction, y will never be that value. Those are my two asymptotes. And we know reciprocal functions from our last experimentations look like this. Boom. And then we're going to do the same from down here. We're going to approach those asymptotes, but not cross them. That's why they're asymptotes. Now, of course, if you are having trouble remembering what graphs look like, you are always welcome to, why don't make a t-chart where we know 0 is going to have an undefined y, and then you can plug in some negative values. Since we have a 2 on top, I'm just going to plug in 2's, boom. And you can see the values that we are going to get, and then you know as x increases without bound what is going on. So you can see what's boom, boom, and nice and easy. So when we get together, let's do this one in class. This one's a little trickier. I'd like to do this one in class for us. Alrighty, so take a note of that. We'll graph it together in class. So rational functions written in the form above, we're going to use our rules of transformations. We just talked about that. However, not all rational functions can be rewritten in this form. So what we're doing is we are going to use, notice this isn't as simple because we have a binomial and a binomial. So let's use a calculator or Desmos to investigate the behavior of this expression as x grows without bound. Alrighty, so I took a break and I graphed this. I've graphed f of x equals 6x plus 5 over 2x minus 3. And what we want to look at is what happens to this function as x approaches positive infinity and negative infinity. What does that look like? Oh, not what I wanted to look at. Boom, there we go. Alrighty, so as we get closer and closer, as x gets very, very, very positive. Look at this. We're already up. Which value does it appear to approach as a horizontal asymptote? Well, that's 1, 2, 3. We're getting very close to y equals 3, but we're not quite touching it. That's as we get incredibly large on the positive infinity. Well, what if we're going to the left as we get more and more negative on the x-axis? Look at this. We're getting negative and negative, and it looks kind of like we've got a flat line now, but believe it or not, it's not flat. It's going up incrementally small. It's just getting closer and closer to the line y equals 3, but it's never touching it. It's getting super close, but it's not touching it. So how are we going to say that? Well, as x is approaching positive infinity, f of x is going to approach 3. And as x approaches negative infinity, again, f of x approaches 3. That means we have a horizontal asymptote at y equals 3. Well, does there appear to be any value that would be a vertical asymptote for this function? So if we look back at our graph, is there a line, is there an x value that I seem to approach but not cross? So if we look and y is getting incredibly, incredibly negative, is there a y value that I appear to approach? I was thinking 1 there, but look, it crosses 1. And then it keeps getting bigger. It's going down, and we're getting closer and closer and closer to 2. And when we go this way, look, doesn't it appear? It's the other way that we're looking like we're approaching 1, but not touching it. So my vertical asymptotes appear to be around x is 1 and 2. But if you remember, now here's what's really cool about a discontinuity. Remember, the bottom of any fraction, 6x plus 5 over, this is the one we're looking at, over 2x minus 3, we know the denominator cannot equal 0. So we know 3, that'd be a positive 3. We know x cannot equal 3/2 or 1.5. So there's also going to be a discontinuity at that point. So we're going to talk more about our asymptotes. You know what, why don't we've got some time. So when we look at our asymptotes, here's how we're going to determine them. So we always start by factoring our numerator and our denominator. You know what? We're actually going to do this in the next video, because then we're actually going to apply that. But looking ahead, if you want to read these, and then I'll do my best to answer the questions when we go over it. And we'll start right here in the next video. I'm going to go back over how to determine the asymptotes, and then we're going to find those asymptotes in the next video. And if you got any questions over what we did, let me know so we can do them in class. Have a great one, everybody, and I'll see you when I see you.